Welcome back, everybody. We are still sending live from BASF's booth here at Friedrichshafen, Germany, live from Fakuma 2021. And I'm really excited to host our next expert discussion right now with my colleague Mark Ottens, who just arrived.
Hi Richard, nice to meet you here again.
Hi, nice.
I'm really surprised how many visitors are on the Fakuma and especially on the booth already. So it's a really good atmosphere here.
Well, of course they are here because you got so many nice things to offer, and we're going to talk about one of them.
Exactly. Yeah, exactly.
We're going to talk about Elastollan, a true material all-rounder, and specifically sustainability here.
Yeah, that's right. So today we are talking about Elastollan, a thermoplastic polyurethane, and the key focus of today's discussion should be sustainability, and that's what we will describe today a little bit more in detail.
What sustainable applications are there for Elastollan? Yeah. Tell me a few, or one maybe.
Yeah, okay. So there we have different options. So on the booth today we have two samples where we have sold Elastollan into sustainable applications. One example is the electrical vehicle charging cable. You can see here where thermoplastic polyurethane is used. On the one hand, due to the very good performance of the material, so the abrasion resistance and the flexibility and so on. And the most important criteria why thermoplastic polyurethane is used in such applications is the design freedom. Yeah? So you have really a very broad building box where you can design the material in the right direction, how it's requested from the customers. So, and that's an ideal example for the design freedom of thermoplastic polyurethane. As you always, for EVC charging cable systems, you have to consider the design of the cable.
Okay.
Because the cable have to be flame retardant, and the flame retardant properties depends on the cable design.
Okay.
And therefore, you always have to consider during the development of the thermoplastic polyurethane, at the end, the cable design and the customer is integrated really in the development process. So there's not one solution available. There are several solutions available for EV charging cable systems, depending really on the individual application of the EV charging cable.
So you have to be working together quite intensively with customers to match their design requirements.
Exactly, that's exactly what we do. So normally if we develop something for such an application, first we start off with the general requirements we need. And this is something we get from our customers, and then we start off with the first development, and then the customers always get a sample in the first approach, they test it, and then we get a feedback, and then we modify it in the right direction.
I mean, I'm seeing a lot of those cables these days. I mean, right in front of my hotel there are a number of charging stations. Here at the Friedrichshafen Fairground there are a number of charging stations. How big has this application become for you at BASF?
Yeah, it's currently a real extreme growing market, so there's a huge demand for such materials, and we are really lucky that we can participate with thermoplastic polyurethane in such applications, and we really can deliver for all different kinds of electrical vehicle charging systems our thermoplastic polyurethane as sheathing material. This means for mobile charging cables, but also for stationary charging cable systems, so in public areas, but also for wallboxes, for example.
Okay, and we're going to talk about those wall boxes tomorrow in another live talk. One thing that would also be interesting for me is that this is by far not the only solution that BASF has for electric vehicles. How much do you cooperate also with your colleagues in other fields of BASF for electromobility?
Yeah, so there we have a very intensive exchange. So we have working teams who focus on these topics, and there the network is very closed, and if there's a request from one customer also to other applications, we can give them very quickly the right contacts that we can work together on.
Okay, I'm just hearing that we have a question that came in via email to you. What specific grade is being used for those ECV or EV charging cables?
Yeah, okay. There's no specific grade, as I have tried to describe at the beginning. So you always have to consider the individual cable design of the customer, and then we are open to recommend the right grade, or in case if we do not have already the right grade, to develop something new.
Okay.
And yeah, the focus there must be always on the right balance between FR properties, so flame retardant properties, and product performance.
Just a question for me maybe, is this color also part of the design freedom?
It is, definitely.
Okay.
Yeah. So this is one thing which is very important for this EVC cable sheathings. That's not only the mechanical performance, there are some additional requirements we have to fulfill. This is the colorability, so it's able to color in different colors, but also the surface touch, the haptic, and also the matte properties of the surface. You had a tube in your hands where you can see also how you can design a matte surface, yeah,
Okay,
only
yeah.
by processing.
Yeah. Yeah, I see it. This is really bad. Okay. And you can basically fine-tune that to whatever surface it's supposed to
so
have.
we can do both. It could be designed by processing, as you can see in this example, but you can also add special additives to the material that you can get a smooth matte surface finish.
Okay. There's a lot more to talk about. Actually, we have a full table of Elastollan solutions right over there. So Mark, come on over and let's check out what else there is in store.
Okay, so maybe
This is all made from Elastollan.
yeah, this is
Okay.
all made from Elastollan, several applications, and all these products have one thing together. This is what they show at the beginning. I have to say, maybe it's the design freedom of the material. You can see, and this makes the material so interesting for me, but I think also for our customers.
Hopefully.
That you can move into really different applications. And there's a huge diversity. And as mentioned at the beginning, we also have other applications where recycling is important. This is, for example, the Airsign bicycle tube we have introduced last year.
So that's maybe you can tell that again. That is a bicycle tube.
Yeah, that's a bicycle tube. The main goal was to improve the lifetime of a bicycle tube, to improve the performance, so the riding behavior. This means puncture and snake bite resistance and so on. And one side effect was that we also could offer at the end a solution where the tube is made to 100% out of Elastollan, so also the wave and the wave shaft you can see here is produced out of Elastollan. And also here you can see the diversity. You have a very stiff wave shaft and a very flexible tube material. And as the tube is made to 100% out of Elastollan, it's also easier to recycle than cross-linked materials.
It's a one material solution. Okay, what else is there? You can pick your favorite if you like.
Oh, okay. So I will make a quick description about the most parts. So here we have a Chromatic Tube out of a new developed grade. It's Aura 5098 A10 FC. This is a real rounder. We also have presented last year already, where you can combine the properties of an ether with the thermal properties of an ester. So there you really have an improved burst pressure behavior under temperature. Then we have here several sheathing materials for hydraulic tubes, for ropes. Here the abrasion resistance plays a very important role. This is a sorting star made of TPU by injection molding. Here we have a lay flat hose. There you have different kinds of lay flat hoses which were made of TPU. In this case it's a drinking water tube.
Okay.
So we also have applications for cold drinking water, which could be processed. Other applications are fire hoses which were made of TPU, or fracking hoses. Then a complete another market is the belt and profile market. Here you can see a conveyor belt which is made out of TPU. There you have two advantages of TPU. On the one hand, the lifetime is increased due to the abrasion resistance of the material, but also a relative good creep behavior and elasticity is added to the material, which is needed for such a conveyor belt.
Okay. I will just quickly grab my iPad here to check if there is any questions coming in from the chat. One thing that would interest me though, for you as an expert working with the material, do you think that the range of applications is now done? Is there all there is made from TPU, or is there more coming?
Definitely not. So that's why I like personally TPU. You get always something new, always new applications. So for example, the bicycle tube is a real new application. The hoof shoe is also something which is very special. So always new applications will born due to the fact that we can design the material to the individual requirements of also new applications. applications. Nevertheless, also for the EVC charging cable systems, I'm expecting, for example, that we are not at the end. So my dream would be so that we maybe can add also sustainable thermoplastic polyurethane products to such applications, also to these applications.
Mark, the best is yet to come for Elastollan TPU, so we can look forward to a bright future.
Yeah, thank you.
Thank you very much for joining this second expert discussion for today. If you want to ask questions, send us your comments, your feedback, or give us food for thought, or challenge our experts like Mark here, just feel free to use the LinkedIn chat, and then those questions will pop up right here on my little iPad. Maybe you can try in our third live talk for today, which we will have at 4 p.m. this afternoon. Until then, stay tuned, stay positive, and see you later.
BASF. We create chemistry.